Hello all and welcome to a new video on IGCSE Physics Classified Paper 2 questions. Today we'll be discussing the topic of center of mass. The diagrams show four objects A, B, C, and D. The center of mass M of each object is marked on the diagrams. Which object is not in equilibrium? So to determine whether an object is in equilibrium or not, or whether it will topple or not, we draw a vertical line from the center of mass downwards. And if it lies within the object, then the object is in equilibrium. So let's try that here. We just draw vertical downwards arrows from the center of mass. So as you can tell, C is the only one where the arrow falls outside of the base of the object. So the base of the object here is this part here, the red part, and the arrow falls outside of it. For all the rest, the arrow falls within the base of the object. So the only one here that is at the risk of toppling is C. Therefore, C is the correct answer. The diagram shows an L-shaped piece of card suspended freely from a pin at B. When the card is pushed, it swings and then comes to a stop in the position shown. At which labeled point is the center of mass of the card? Again, the trick is to draw a vertical downwards arrow from the suspension point. So this is your suspension point. You draw a vertically downward arrow. The center of mass must lie on this red arrow. So the only point that lies on this red arrow is point C. We do not take the point from which I hang it, and we do not take any point above it. So these are wrong. And D is not on the line, and the correct choice here is choice C. The diagram shows three uniform solid wooden blocks with a square cross-sectional area resting on a horizontal table, which list puts the blocks in order from least stable to most stable. So stability depends on having a wide base. So you want it to be resting on its widest base, the widest possible base. And we also would like to minimize the height. So we want a smaller height and a bigger base to get more stability. So which one is the most stable here? This guy is the most stable. And this guy would be the least stable because it is the thinnest in a sense. It has a very small area in contact with the ground compared to the rest. So if we're going from least to most, the correct answer would be choice A, P, Q, R. A hole is drilled in a square tile. The diagram shows the tile hanging freely on a nail. Where is the center of mass of the tile? So again, what we do is we draw a vertically downwards arrow from the point of suspension, which is the nail, pretty much. So A and C are not on the arrow, so we automatically disregard them. So where do you think the center of mass is? Is it at D or at B? Of course, common sense says that the center of mass is going to be at D. The diagram shows four solid cones. The center of mass of each cone is marked by a point. Which cone is the most stable? So the most stable diagram or the most stable cone is the one that has a wide base and a low center of mass. So the lower the center of mass, the more the stability. So compared to A and B, we can automatically see that C and D have lower centers of masses. The M is at a lower point, so we can just disregard A and disregard B. And then we can compare C and D. And of course, D is the most stable. A heavy truck on wheels has a platform attached to it. A man stands on the platform. The truck does not fall over. Which position A, B, C, or D could be the center of mass of the whole system? Like we said before, so in order for this cart not to topple, I have to draw a vertical line downwards from the center of mass, and it has to lie within the base of the object. So let's draw vertical lines. And let's highlight the base of the object. This is the base of the object. So the only vertical line falling within the blue horizontal line is B. So if the center of mass were at A or C or D, it would absolutely topple because the vertical line falls outside of the base. So therefore, the correct choice here is choice B. We've already done this question before. It's the exact same question, and we got the answer to be D. The diagram shows 4 table lamps resting on a table. The position of the center of mass of each lamp is labeled X. Which lamp is the most stable? Like we said before, for stability, we want the center of mass to be at the bottom. So let's automatically ignore A and ignore C as well. So we're comparing B and D. Which of these is more stable? The one with the wider base. So if you compare the two bases, you can see that B has a wider base. So B is the most stable arrangement here. The lamp in the diagram is not very stable and falls over easily. Which row shows changes that would definitely make the lamp more stable? So for more stability, do you want the center of gravity to be higher or lower? We already said that we would like the center of gravity or the center of mass to be lower. So I automatically disregard A and C. For the base, do we want it to be narrower or wider? Of course, we want the base to be wider. So the correct choice here would be choice D. This is, by the way, the core concept of center of mass. To increase stability, you want a wider base and a lower center of gravity. Moving on, point X is the center of mass of a lamina in the shape of a triangle with sides of equal length. The top of the triangle is cut off along the dotted line. What happens to the center of mass X? So the center of mass is basically like the average of where the mass is distributed along the shape. So with the whole triangle there, the center of mass is at X. If I remove this part, what happens to the center of mass? So I removed a part from the top, which tells me that more mass is now concentrated at the bottom. So where would the average be? The average would move down as well, because I removed a part from the top that was affecting the center of mass. Now, since it's gone, more power is given to the part at the bottom. So the center of mass, which is a representation of the average, will move downwards as well. So the correct choice here would be choice A, moves towards the bottom of the page. The diagram shows an aluminum sheet of constant thickness. 4 significant points on the aluminum sheet are labeled P, Q, R, and S. How can the center of mass be found? So the way to find the center of mass is to pin this object at different points like P, Q, R, and S, and then draw vertically downward lines from where they are. And where they intersect is going to be where the center of mass is. So let's read the choices and see which one of them is closest to what we just said. A says by finding where a line from P to R crosses a line from S to Q. This is incorrect. By suspending the sheet and a plumb line from Q and finding where the plumb line crosses a line from P to R. Again, this is incorrect. By suspending the sheet and a plumb line from P and then from S and finding where the plumb lines cross, this is the correct answer. The vertically downward line is called the plumb line, and we draw 2 of these and we see where they cross. So again, D is incorrect. You need 2 plumb lines and you need to see where they cross. So the correct choice here is choice C. And this brings us to the end of our video. Thank you all for watching. I hope this has been valuable.